So it's one of the trig function, right? So is it sine or cosine?
Sine.
Right, it looks like the sine wave. So we know it's going to be y equals a is the amplitude sine of k x plus or minus b, where k is the frequency of this function and b represent if you have a horizontal shift left or right. So now if we want to find k value, well, k can be given by the formula p is equal to 2 pi over k, where p represents the period. So if I want to find p for one cycle of this function, I just need to find the length from here to here, because that's one complete period. So if we find p, well, p is going to be 2 pi over 3 minus negative 2 pi over 3. Sorry, pi over 3. That's the length for one period. And then if you add this up, this is going to be 3 pi over 3, which is simply pi. So we know p is pi, so that's what we're going to plug in here, and then that will give us the value for k. So if I plug in p, which is pi, and then try to solve for k, we can just kind of cross multiply, solve for k. So k is going to be 2 pi over pi, which is simply be 2. So k is 2. So for the equation, we know what k is, so check. Now, do we know a? Do we know the amplitude of this function?
Yes, it's 6.
Right, because the height is 6, and then low it goes negative 6. So we also know a, that's 6. Now, the only thing we need to find out is what is the b value, meaning if there is a horizontal shift from the basic sine function. Now, it looks like the graph has been shifted left some units. So what is that b? So remember, the original sine graph looks like this for one period. So this point was at 0. This looks like it starts at negative pi over 3. So that means, do you agree that b is positive pi over 3 because you're going to the left pi over 3 units? Maybe,
yes.
Right? Mm-hmm. So we can say b is going to be positive pi over 3 because we know when we do transformations, we follow the opposite direction. So we know b, we know k, we know a. So the equation would be, so let me hide this for now. So the equation for this graph is going to be y equals, so a is 6, and we have a sine wave of k is 2 times x plus the horizontal shift pi over 3. So that will be the equation for this graph. And then if you want to distribute the k value into the equation, you can also say this is y equals 6 times sine of 2x plus 2 pi over 3. You can also write it that way too. So any of these are equivalent. Okay. So Miriam, any questions for this problem?
No, I understand now. Thank you.
Okay, great. All right, so those of you who are just coming in, welcome. Hopefully this is helpful for you as well. Now here is another question that is also covered in this course. Now this is, so it's either a growth or a decay. So it looks like it's a growth problem. So go ahead and take a couple of seconds, read the question, try to see what they're asking you to find, and then just write down your ideas and then we'll start. Okay, so for this problem, so the good thing is we already have the model, so you don't have to come up with the model. Usually the one we did in class, we would come up with the model and then figure out what we're asked to find. But here we have a model, so we're going to use it and then try to find what we're looking for. So growth of a certain strain of bacteria is modeled by this equation. So we have sum G is equal to A times 2.7 to the power 0.584 T. Oh, okay. So it's not such a nice number because we're not allowed to use a calculator. But for this one, you might want to use a calculator since we have decimal and it's not so pretty. So it's okay if you use a calculator for this question. But on the test, of course, the numbers are simpler so that you can do it mentally. You don't need to use a calculator. Now, G represents the final number of bacteria. So that's sort of like the A of T we had in class. And then A represents the initial amount. So that's the amount you start with. And T represents time. Now, we want to know approximately how many hours will 4 bacteria first increase to 2,500 bacteria. Interesting. So what does that mean? What are we looking for and what is given? Anyone wants to try?
You have the final number of bacteria and you have to find in how many hours you will get that final.
Mm-hmm. So we want to know what time will it reach this much. So we know G, that will be 2500. And what does the 4 bacteria represent?
The initial number of bacteria.
Mm-hmm. So we're starting with that much, and then we want to see what time will it grow to 2,500. So we're starting with A, which is 4. And we want to know what is the time that this will take place. So let's plug everything in. So we have 2,500 is equal to 4, 2.7 to the power 0.584 t. Okay, so now I'm going to use my calculator too. So first thing you want to do is to isolate t. So t is an exponent, so let's get rid of the 4. So we divide both sides by 4. So if I do 2,500 divided by 4, that's about 625. And then we have 2.7 to the power 0.584 times t. Well, now, how do I bring down my variable? It's an exponent.
Can you do ln?
So we could do ln, or we could just use log base 10. Now, because this question doesn't involve e, you could use ln. Yeah, right. It's not a big deal. We could use ln, or we could just use common log. I'm going to use common log, but no big deal. You could use ln. So let's do log of 625 is equal to log of 2.7 to the power 0.584. Now, if you use ln, your answer is just going to be off by a tiny decimal, which does not affect our final answer. So it's okay to use ln. So now I can bring down the exponent because that's the property of logarithm allows us to do. So we have 0.584 times t times now log of 2.7. And then we have log of 625 on the left side. And then the last thing is to solve for this variable t. So I divide by everything that multiplies t. So we have log of 625 over 0.584 times log of 2.7. So that's the time. Now, because we're not allowed to use a calculator, this should appear as one of your choice if it was our test, but because this is good enough. Now the rest is plug it into the calculator and get the value. Now, if anyone wants to plug this in, so my calculator doesn't do this thing because I'm using my phone and I don't know how to use log on my phone. Miriam, did you get an answer here?
I had gotten 11, but I got it wrong.
What's the decimal? So we might have to consider that.
I think it's 11.3, but let me do it again in my calculator.
Okay, so we want to collect the decimal as well. So if anyone else could put this in their calculator as well, please do that.
I got 11.0984.
Okay. All right, so that's approximately 11 hours and some change, right? Now we want to know, what do we want to know? We want to approximate how many hours will 4 bacteria first increase to 2,500. and round it to the nearest hour. So, well, we know it takes 11 hours and a couple more seconds to be at 2500. So that means I'm going to round this off to 12. Because we have extra little second until we get to 2500, right? So that way I'm going to round up to 12 hours so that we have exactly 25 at the first count.
What I did was I just left it as 11 and I got that.
Okay, yeah, so the key idea was we still have a couple more seconds running, right? So because it's a growth problem, I would go to the next hour, which will be the 12th hour. So that way we have exactly 2500 count, and then we could have more. But the first 25 will happen after the 11th hour. Does that make sense?
Yeah, thank you.
No problem. All right, so there you go. This was section 4.5, I believe, when we worked on growth and decay problem. Okay, so any questions on this topic? Okay, so any other questions you guys would like me to go over?
Is it all right if I ask you if you could go over one of the questions from the spring 2019 final?
Okay, so let me pull it up. Spring 2019. Which question is it?
The first one.
The first one. Okay, so all right. So let me copy this to my app. Okay, so can you guys see this?
Yes.
Yeah. Okay.
Yep.
Great. So so we want to, what do we want to do? Simplify this. So we want to verify the right-hand side is equal to the left-hand side. Now think of it as you don't have this, okay? Because on the test, you're probably not going to have the other side. You want to show it's equivalent to something. So let's see if we can just simplify the left side, or just this giant expression, and then see if it simplifies to something nice. So it looks like I have cosine 2t, sine 2t. Now that should remind you of something, right? What does this formula remind you of?
The double angle formulas.
Yeah, right, because you have 2t, so that should give you a click. Oh, I should use double angle somewhere in here. So, or another approach would be to separate the two fractions. So one approach would be to separate, so you have 1 over sine 2t minus cosine 2t over sine 2t. So that's one approach. Another approach to just go straight into the double angle formula and simplify. Now, I think I'm going to just plug in the double angle formulas. I think I want to do that. Right? Do you guys want to do it that way? So I'm going to do that because this is not going to simplify much if I separate them. So I'm just going to go and plug in the double angle formula for cosine 2t and sine 2t. So what is cosine 2t?
That'd be cosine squared t minus sine squared t.
So that's one version, cosine squared t minus sine squared t. Now that's the one I asked you to remember, okay? And the other one you can always derive them. So that's fine. Now what about sine 2t? What's the formula for that one?
2 sine t cosine t.
Oh, tell me one more time.
2 sine t cosine t.
Yep. Great. So now let's plug these in and then see what this simplifies to. So we want 1 minus cosine 2t over sine 2t. Well, we still cosine 2t can be replaced with that formula. So we have 1 minus cosine squared t minus sine squared t, right? And then all over sine 2t will be 2 sine t cosine t. Okay, so now I can go ahead and distribute the negative out just to simplify this. So this is 1 minus cosine squared t plus sine squared t all over 2 sine t cosine t. And then now here, this should also look like some identity. Maybe the top, right? So you should recall this identity. Sine squared t plus cosine squared t is 1. Now, if I subtract cosine on both sides of that identity, I have sine squared t is equal to 1 minus cosine squared t. Okay. Do you guys see that? I can replace that right here. Right? So let me know if you don't see that, or stop me if you need me to explain that again. So I can replace sine squared t for this piece right here, because I can manipulate the Pythagorean's identity. So we have a sine squared t plus sine squared t from before over 2 sine t cosine t. And then sine squared t plus cosine sine squared t is what? Like term, right?
2 sine squared t.
Mm-hmm. So that will give us 2 of the same group. So we have 2 sine squared t over 2 sine t cosine t. And here it's going to simplify. So the 2 will cancel out. I can cancel out sine t with one of the sine t from top, and I'm left with sine t over cosine t. Now what is sine over cosine?
Tangent.
Tangent. So this would, all of that simply comes down to tangent. And now you check that have we accomplished what we needed to do? Yeah, right. So let's bring it back. There you go. So that's the, that indicates that we have verified our identity. So this is equal to the right-hand side. So, okay.
So on the test, you might ask, like, which of these 4 options could this left-hand side equal?
Right, which of these are equivalent to blah, right? The left-hand side of this. And then you'll see tangent as one of them, and then you'll see a bunch of other options, and then you'll pick the right one. Okay. All right, so any other questions? All right, so I'll give you guys just a couple of seconds, see if you come up with any other question, and then we can start again. So spring 2019, 21. All right, so 21, this one, right?
Yep.
Yeah. Okay, so let's copy that question here. Okay, so you're given a function and you're given some z values from -2 to 0, and we want to determine the net change and the average rate of change. Okay, so so what's the formula for net change? Do you guys remember?
Wasn't it x2 minus x1 over 2?
No.
No.
Net change. So the net change is the change in the function values. So it would be f of b minus f of a. That's the net change. And then for the second part, you're looking for the average rate of change. So the average rate of change is pretty much the slope. Okay. So you can think of the slope formula we had for lines. You can just translate everything using function notation. but that'll be a quick way to remember average rate of change. So the average rate of change is f of b minus f of a over b minus a. Okay, right? Looks familiar? We did them in a while ago, right? Like beginning of the semester. So if you need to look it up, just make sure you do. So a is always the first x value. In this case, it's the z value. So this would be our a, then this would be our b. So now let's find what is f of a and f of b. So f of a, it's going to be f of -2. So I plug in -2 into my function. So that would give me 5 minus 3 times -2 square. So you plug in the input wherever you see that independent variable is. So we have 5 minus, so -2 squared is 4. You times it by 3, that gives you what, 12? And then you do 5 minus 12, that's about -7. Okay, so that's our f of a. Now f of b, we do the same thing. We plug in b value into the place of z, so that would be f of 0. So we have 5 minus 3 times 0 squared, which is 5. So that's our f of b. And then we plug this into our formula for net change. F of b, that's f of 0, minus f of a, that's f of -2. And f of 0, we found that to be 5. And f of -2, we found that to be -7, so minus -7. So we're really doing 5 plus 7. So that would be 5 plus 7, which is 12. So that's the net change between z equals -2 and 0. And for the average rate of change, you already did a lot of work. All you have to do is plug in the net change over b minus a, right? So you can say, well, we already found f of b minus f of a. That was 12. And then we just do b minus a. So our b is 0, and our a is -2. So that's 0 minus -2. That would be 12. Oh, I already gave you the answer. Okay. 12 over 2, which is 6. So that's the average rate of change. Okay, so these are the procedure for these kind of problem. So you have to find the net change. Even if the question didn't ask you for this piece, you still have to do the net change because the average rate of change is simply net change over b minus a. So you still have to do that work. So any questions on this, Andrew?
No, once we got the formulas, like it made a lot of sense.
Yeah,
It had just been a very long time since I had seen a question like this.
Right. So a lot of things we did in the past, right? Like 3 months ago, 4 months ago, maybe not 4 months, but a while ago. So make sure you review those notes because it's cumulative. So anything can show up, right? So I'm going to move on to the next problem. So someone wants to see, so Mariam wants to see 2 from spring 2019. So let's do that. So number two. This is spring 2019. Now here is number 2. So let me crop this here. So we have number 2. Okay, so for this problem, we want to use the function f and g to evaluate and simplify the following compositions. Okay, so we're just composing this function in 2 different orders at same x value. Okay. So what I would recommend you to do is find what this composition is, find what that composition is, and then just subtract their results. Okay. So we're going to find f of g of -1. So how do we do compositions, guys? Anyone remembers?
You do the inside first.
Right. So you start with the most inner function, you find what that value is, and then you plug that into the outer function. So we're going to figure out what this is So F is still waiting outside. We're going to work with G. So G is going to do 5 minus, so this is what G is going to do. So it's going to do 5 minus 1 over x, while x is replacing with -1. And then we figure out what that number is while F is waiting. So this is 5 plus 1, because double negative is a plus, so that would be 6. Now that becomes the input for F. Now F is going to do this. It's going to do 2x minus 3. So we have 2x minus 3, well, x is 3. No, wait, sorry. What the heck? X is 6. And then we just figure out what this value is. So 6 times 2, that will be a 12 minus 3. And this is going to be 9. Yeah. So this is 9. So that's what we're going to replace right here. And then for the second piece, we want to find g of f of -1. So we do the same thing. We now do the inner function, and then whatever results we get, we plug it into the outer function. So now we're working with f first. So g is going to be waiting outside, and f is going to do 2x minus 3. So we have 2x minus 3. X is -1. So let's figure this number out. So we have g of, so 2 times -1, that's -2 minus 3, that's -5. And that's going to be the input for g. And g is going to do 5 minus 1 over x. So this is 5 minus 1 over x, while x is -5. And then we add them up. So this is really 5 plus 1 over 5. Now, how do we add two fractions?
You need the same denominator.
So what will be the LCD?
5.
5. So this one needs 5 over 5. So we have 25 over 5 plus 1 over 5. And now we can successfully add the top. So we have 26 over 5. So that's what we're going to replace in the second piece. So right here. And then we just subtract them. So we're doing f of g of -1 minus g of f of -1. And then we found f of g of -1, which is 9, minus g of f of -1, that's 26 over 5. And then again, using common denominators, we combine them. So we multiply this number with 5 over 5, because that's our LCD. So then we have 9 times 5, that would be 45 over 5, minus 26 over 5. And then we just subtract them. So 46 minus 20, no, sorry, 45 minus 26. That's about
19.
19. Thank you. Yeah, so there you go. So it'd be 19 over 5. And we're not able to simplify that because 5 doesn't go into 19, so you'll leave it in fraction form. All right, so any questions on this problem? All right, cool. All right, so again, look through this test, or if you're looking at any other final from the past, let me know which question you guys would like me to go over.
Could we go over number 20 from this final?
Okay, so 20, let's do that. 20, 20. Okay, so here's 20. Okay, so here's 20. We want to find tangent t given these conditions. So what do you guys think? How do we do something like this?
You have to do the triangle first.
So we're going to draw the triangle because that will give us all the sides, and then we can figure out tangent. So let's do that. So, which quadrant is our triangle lies in? How do we know? How do we know, right? That's the first question.
I think it's just on first glance, it's either 3 or 4
3 or
because
4?
sine is less than 0.
And we know that it's cosine, so I think it will be in the third quadrant.
So cosine is also negative, so that's this one and this one. So the two conditions are satisfied right here. So that means, you know, the triangle that we're going to draw will be on the third quadrant. So here's our right triangle. And t is this angle from the origin. And then we're giving cosine of t. So cosine is adjacent over hypotenuse. So this is opposite. So that means this is adjacent, this is hypotenuse. So now you have to figure out what the missing length is. The missing length is the opposite. So how do we find the missing length? So we're going to use that a squared plus b squared is equal to c squared. And then we know that we're missing one of the leg, so you can call it a or b and then just fill in for the other one. So let's call it a is missing. So b is -7 square. And then c is 11 square. So we have a squared plus 49 is equal to 121. And then, so what is the value for a, guys?
Square root of 72.
So plus and minus. And we can simplify this, right? 72 has a perfect square, so it will be 36 times 2. So that means a is really 6 square root of 2. Now, is it plus or minus? Which one do we pick? Right, so we're going to pick the negative one because this side of the triangle is parallel to the negative y-axis. So our question mark has to be a -6 square root of 2. Okay, and now we have the triangle completed, so we can figure out what we're looking for. We want tangent of t. So tangent of an angle is equal to opposite over adjacent. So we have opposite, which is -6 square root of 2, and adjacent is -7. So that simplifies to 6 square root of 2 over 7. So that will be the exact value for tangent. And you can check from ASTC that t in the third quadrant means positive and cotangent as well. So we have a positive value. So everything makes sense. Any questions on this problem? All right, so moving on. So we want us to work on number 6 from the same final. So let's do number 6. There you go. So this is number 6 from the same final. So let me copy it here and then we can work on it. So we want to find the exact value for the composition of trig and inverse trig. So, okay, so what is sine inverse of 0? What is that? So you do the inside first, always. You do the inner portion and then the outer portion, just like we did for composition of regular polynomial functions. So we want to know what is sine inverse of 0 is, and then whatever we get, that's what we're going to evaluate cosine. So what do you guys think?
Sine inverse of 0 is, I think, 0.
You sure?
We're asking what angle will give us 0. Oh, so is that 2 pi?
Well, you got it right on the first time.
Oh, okay. Okay.
But 2
Oops.
pi is also right. 2 pi is also right. But we're going to go with 0. Okay? because they're the exact same thing. 0, 2 pi, 4 pi, 6 pi. They're all terminates at the same point. So we're looking right here on the unit circle. So 0, and then if you go around, that's 2 pi. And then if you go around another cycle, 4 pi. So they all have same exact value. So it doesn't matter which one you plug in, but we're using 0. So sine inverse of 0 is going to be 0. So we're looking at cosine of 0. Okay. Now what is cosine of 0? So cosine of 0, 1, because you're still looking at that point, and then the cosine is the x value, so that's going to be 1. Now we go to the next part. So now we want to do cosine inverse of 0. So now cosine of what angle gives you 0? Right, so it's right here. Pi over 2. So cosine inverse of 0 is pi over 2. So we're evaluating sine of pi over 2. And then now, what is sine of pi over 2? So again, you're looking at this point. So we have 0, 1 as the terminal point. So sine is the y-coordinate. So sine of pi over 2 is 1. And then we add them up so that the result is 2. Any questions?
I have more of a hypothetical question about this.
Mm-hmm.
If we were doing this equation and it was like, find the exact value of cosine of inverse sine of like 5 over 7, something that we like didn't just, it wasn't really on our chart, we wouldn't have memorized. Would you solve that by substituting in theta for that?
Yep.
And then working?
Yep, you got it.
Okay. Could we go over that real quick if no one else has questions about the actual problem we just did?
Okay. So does anyone else have any question on number 6? Okay, so it looks like we're okay. So now for number 6, we were able to find the angle or the exact value right from the unit circle because they happen to be on the unit circle. But if we have something like a real number such as 5 over 7, and we don't really have an angle that will give us 5 over 7 that we memorize, right? Or we know from the unit circle, other than really using a calculator. So if you want to find exact value of such question, then you have to come up with the substitution and then you construct the right triangle. Find the missing length and then you have everything you need. So we're going to call this theta. So we're going to let theta be equal to sine inverse of 5 over 7. And then to cancel the inverse function, we apply sine on both sides. So we have sine theta is equal to 5 over 7. Yeah. And then, well, from here now we can construct the right triangle. So we have triangle here. Oh, that's not so right triangle. Looks weird. Okay, here. Oh, not again. Okay, so that's our right triangle. And then we fill in what are we given. So suppose theta is here. Across from theta is opposite. So that would be 5. And then we have hypotenuse 7. So you just need to figure out the missing length. So to go ahead and find the missing length, so 7 squared minus 25. So that would be 49 minus 25. That's about 24. So question mark is a square root of 24, which is square root of 4 times 6. That would be 2 square root of 6. So that's what question mark is, right? We're just simply using Pythagorean's theorem. So now that I have that, now I can come back to my question right here. Well, I'm looking for cosine of theta. because we use the substitution theta to figure out what the inverse function would give us. And now from the triangle, you read off what is cosine theta is. Well, cosine is adjacent over hypotenuse. So that would be 2 square root of 6, that's adjacent, over hypotenuse 7. So that will be the exact value for something like this, because we don't have memorized what is that angle that will give us this exact value, which is weird. Does that make sense, Andrew?
This does totally make sense. I remember on a past quiz, we had one similar to this. It was like one more step than this, and it was where we didn't know 2 sides of the triangle.
Right. So I think I know which one you're referring to. Probably something like this. So we probably had like let's see. So not exact question, but maybe cosine and then sine inverse of a over 5, something like that. And then I give you a restriction on a, where a has to be between -5 and 5, or else the answer wouldn't exist, right? Because the sine inverse has to lie between -1 and 1. So something like that, right? Is this what you were referring to, Andrew?
Yeah, this is it.
Yeah, okay. So treat a as just any real number, and you do the exact same thing. Okay. Do you want me to work on this?
Nope.
Nope.
Yeah, now that you've like set it up and talked about it, the process makes sense.
Okay. So you'll do the same thing. You would use a as part of your answer. So your answer will involve a with some bunch of other terms. And whatever that a value is, that will be the exact number. Well, the procedure is the same. You come up with a substitution for the inner function, which is sine inverse of a over 5. And then you take sine on both sides. You have sine theta is equal to a over 5. Draw the right triangle, figure out the missing length in terms of a, and then read off what is cosine theta in terms of a. Okay, cool. All right, so any questions on inverse function and their compositions? All right, so let's go ahead and move on to the next problem from spring 2019. We have, next problem is 15. So let's check 15. Slowly, 15. Okay, so here's 15. And so let me go ahead and, oh, okay, so this is also something we did in the past. All right, so the key idea with this question is to know what does it mean to be a parallel and perpendicular lines. So just to recap quickly, do you guys remember how do we know if 2 lines are parallel and perpendicular?
For parallel, they have the same slope, but for perpendicular, it's the reciprocal, the negative reciprocal.
Yep, you got it. So those are the 2 key ideas when you're working with line, when you have a question that says to compare these lines and determine which ones are parallel or which ones are perpendicular or which ones are neither. So make sure you know how to do that. Just compare their slope, okay? So for this one, we want to just go ahead and find the equation of the line with x-intercept of 6. So what does that mean? Can I write that as a coordinates point? So x-intercept 6, that means, so if I want to write that as a point, that would be 6, 0, because your y is 0 when x is such value. And then we want that line to be perpendicular to this line right here. Well, what does that mean? We want the slope to be perpendicular to this given line. So let's go ahead and find the slope of this line, and then we're going to negative reciprocate the slope. Okay, so that's the idea. So let's go ahead and do that. So I'm going to use white. So we have 2x plus 5y is equal to 9. And then I want to solve for y, so I subtract 2x from both sides. 5y is equal to negative 2x plus 9. And then I divide both sides by 5. So I have y is equal to negative 2 over 5x plus 9 over 5. So there you go. That's the slope of this line. I want a perpendicular slope. So what's my perpendicular slope? So this would be 5 over 2. So you negate and you reciprocate the slope. So now we have a point, we have the slope, so write down the equation of the line. So we're going to use the point-intercept form. Y minus y1 equals m times x minus x1. And then this is x1, y1, and this is our slope, which is perpendicular to the given line. So let's plug these in. Y minus 0 is equal to 5 over 2 x minus 6. So that's the equation of the line. Now, if you want to write this in the other two forms we had, which was the slope-intercept form and the standard form. So for the slope-intercept form, it's really easy because now you just have to get rid of that 0 and distribute 5 over 2 on the right side. So we have y is equal to 5 over 2 x minus, and then when I distribute 5 over 2 to negative 6, I can cancel out a factor of 2, so I have 15. So that will be the line in slope-intercept form. Now again, whichever appears in your option, any of these are fine as long as you know how to get to the line. And then if I want the standard form, so it's also good to know how to write that one. What are the conditions on standard form? You have to make sure that there's no fraction, and you also want to make sure that your x component is positive. So I want to get rid of my fraction, so I multiply everything by 2. So we have 2y is equal to 5x minus 30, and then I just move 2y to the right side and move the 30 to the other side. So we have 30 is equal to 5x minus 2y. So that's the standard form. Now, some textbook does move everything to one side, so it doesn't really matter if you want to move everything to one side, set it equal to 0. That's really up to you, and that's really up to whichever options you see on the test. So, but know that there's no fractions when you're writing an equation of a line in standard form. Okay, so there you go. That's number 15. Any questions on this?
Hey, I'm sorry, but I missed the step of how you got between y minus 0 equals 5 over 2 times x minus 6 to the result, to the final one in slope-intercept form.
From there to there?
I have all the things I need.
So,
Exactly.
so let's do that. So what I did was, so I dropped the 0 because y minus 0, that's just y. So we have y equals, and then here I distributed 5 over 2. So we have 5 over 2x minus 5 over 2 times 6. And then I simplified it. So 2 goes into 6 3 times, and then that's negative 15. Okay?
Thank you.
No problem. All right, so that's 15. Any other questions or comment on 15? All right, so let's move on to the next question, which is 16. So here is 16. So let me copy this to my OneNote again, and then we'll work on it. So, okay, so here's number 16 from the same final, and we want to simplify. Oh no, we're actually solving. Oops, I didn't see the equal sign, okay. So let's solve this equation. So what do you guys think? How are you gonna solve this? Any suggestions?
Absolutely.
Would you start by distributing the 2x to the 3 halves into the parentheses, and then maybe factor out something?
So, so I'm not gonna distribute because it's already factored for me. So it looks like it's a times b equals to 0, right? It's in that form. So you can think of this is your a and this is your b. So it's already in factored form. So I want to keep it in that form. I don't want to distribute because then it'll be difficult for me to come back to this form. Do you see that, Andrew?
Sure.
Yeah.
Yeah.
Okay, so we're not going to distribute for this one. But yes, you had the right idea. If we had more terms, say like -3 over there. So I don't know if you can see that. So -3 equal to 0. And then I would actually have to distribute, collect terms, and then refactor. But this is already nice. So you have two products equal to 0. So we're going to keep it. And then just set each one of them equal to 0. Because from the 0 product property, we know if a times b equals 0, then we know either a is 0 or b is 0. Right? We know that. So we're going to use that. So I know 2x to the 3 half is 0, or a square root of x minus 1 over square root of x is equal to 0. So I know that from the 0 product property. So if I set the first one equal to 0, what is x equal to? So we can divide both sides by 2 and then take the square root and then take, you square both sides and then take the cube root, you get x equals 0. So that's for the first equation. Now what about the second equation? When I set it equal to 0, well, looks like I got to do some work, right? So I want to combine the top and the bottom. So think of this as over 1. And then you combine them using common denominators. So what's the common denominators to combine these two numbers or expressions in this case? So that would be a square root of x, okay? Because you want this denominator to appear for the next term. So we have a square root of x times square root of x, that's x squared, minus 1 over a square root of x equals to 0. So I combine the denominator for these two terms. So now that I have a top and a bottom for this equation. So now I can factor this. The top will factor into difference of two perfect squares. That's x plus 1 and x minus 1. And the bottom just stays as a square root of x equals to 0. And then we set the top equal to 0. And we know the bottom cannot be 0 because or else we run into trouble. So if I set the top equal to 0, we have x plus 1 equals to 0. That gives us x equal -1. And then if I set the second factor equal to 0, x minus 1 equals 0, I have x is equal to 1. Great. So I have 3 possible solutions. We have 0, 1, -1. Now I'm calling them possible because I have to check, does any of these give me 0 in the denominator, or does it give me negative inside the radical? Because then we run into trouble. So go back to the equation. Can 0 be a solution to this equation? So Andrew says no. Good. So 0 cannot be a solution. So we have, and then, so 0 is not a solution. So I'm going to reject that one. So this is not possible. Now, can 1 be a solution to this? So check, plug in 1 into x and see if it's true. So now if you have difficulties checking your answer, you can also kind of distribute this and simplify. So I'm going to go with what Andrew said earlier, but I'm going to do that to check the equation, but not to solve it, because then solving I wouldn't want to do that. So if I rewrite these radical as exponents, we have 2x to the 3/2 times x to the 1/2 minus 1 over x to the 1/2. Set it equal to 0. So if I distribute, I'm going to add their powers. So I'm going to just write it here. So we have x to the 3/2 times x to the 1/2 minus 2x to the 3/2, and then minus, oh sorry, not minus, I already have the minus in the front, times x to the negative 1/2 equals to 0. So I distributed 2x to the 3/2 to everything inside the parentheses. Now using the laws of exponents, we're going to combine these powers. So we have 2x to the, so 3/2 plus 1/2, that's 4/2, which is 2, minus 2x to the now 3/2 plus negative 1/2, that's 2 over 2, which is 1, equals to 0. So now let's check. Can 1 be a solution? If x equals 1, you have 2 times 1 squared minus 2 times 1. Is that equal to 0? What do you guys think?
It does.
Yeah, great. Now what about negative 1? If I have 2 times negative 1 squared minus 2 times negative 1, does that equal to 0?
No.
No. So the only solution is going to be that one.
Could you also say that you can't use -1 because if you put in a square root of a -1, that won't be a real answer?
Exactly. So you can also look at that and make that observation. Correct. Cool. So the only solution we have is just x equals 1. Yeah. So there you go. Any questions? All right, so those are the questions I got from you guys. Now let me know if you guys want to see any other questions done. Okay. So hopefully this final went well. I'm not sure if you guys got a chance to finish this. But see, work on it and spend some time looking at these questions. And then along with this one, also work on spring 2018 and 2017 as well. And there are a few more in the mathematics department page if you want to work on those as well to get more practice, do that. And I'll look for solutions to the last two. I think I have those. I don't remember working on spring 2019, so I probably don't have solution to that one. So yeah, so if there are no other questions, we'll end this session here. So, all right, so I will do one more question and then we'll probably end it. So let me do a spring 2017 question 20. So 2017 question 20. Okay. Okay, so here's question 20. Oh, okay, so that's a good question to practice. We haven't done a question like that. So let me copy this to my OneNote again, and then we'll start. So this is from spring 2017. Oh. Okay, so here's the question. And we want to find solution to this trig equation on the interval negative pi over 2, sorry, negative pi and pi. So you're only looking for solution in the interval. So from 0 to negative pi in this direction. So you want solution here and here. And then you also want solution from 0 to pi. So, okay, so you're going halfway clockwise and then halfway counterclockwise. And then we also want solution here and here, going from 0 to pi. Okay, okay, that's a funny interval, but yes, we can do it. So the key idea with trig equation is to isolate the trig expression, and then you see what it comes out to. So I'm going to go ahead and add 1 to both sides. So I have a square root of 2 cosine of t is equal to 1. And then I can divide by square root of 2. So I have cosine t is equal to 1 over a square root of 2. And if you want to rationalize it, that's also good. So this is cosine of t is equal to a square root of 2 over 2. So we're looking for the angle t in the interval negative pi to pi, where the cosine is square root of 2 over 2. Okay, so let's focus on the white one, okay? Just the bottom half of the circle. So cosine is positive, so let's write down ASTC. So cosine is positive in this quadrant. So that means I get an answer for this angle right here. So that's one of my t value. So what is the angle that's on the fourth quadrant that gives me cosine to be square root of 2 over 2? So if you look at your table, or if you remember it, cosine of pi over 4 is radical 2 over 2, correct? You guys remember that? So hopefully you do. So I know t is pi over 4 in the first quadrant, but I want the angle to be on the fourth quadrant. So I'm going to start from 0 and go clockwise. So my angle is negative pi over 4. So that's the angle that'll be on the fourth quadrant. And then the second angle I want is from 0 to pi interval. So then I want to go now counterclockwise. So that's this one right here. That will be the other angle when cosine is also radical 2 over 2, and that angle is pi over 4. And these are the only one within the interval negative pi to pi that gives me cosine to be radical 2 over 2. Because the other quadrant, this is going to be negative. This is going to be negative, so we don't want those values. We only want first and the fourth quadrant. And the only reason this is so restricted is because of this interval that's given for us for t. All right, so that's 20. Any questions on this? Okay. All right, so any other quick questions before we go?
Yeah, I have a question. Can you go over the process of like the difference quotient? Because I kind of forgot.
Okay, difference quotient. So let's do one on difference quotient. So let me see if I can pull up one from here. Do we have one in this exam?
There's one in spring 2019.
Spring 2019, okay. So let's see.
Number 9.
Number 9. Mm-hmm. Okay, so we did that one in class. So let me do a different example, okay? So that way you can re-watch the video from yesterday. You'll see this question was done. Let me do different one so that way you get to see at least 2 examples. How about this one, number 6? Sounds good?
Yeah.
Okay, so let's do number 6 from fall 2018. So the idea is the same, but we're just using different formula for this quotient. So let me copy that here too. So Okay, so we want to find and simplify the quotient f of 2 plus h minus f of 2 minus h and divide everything by h. Okay, so we're going to find each pieces first. So you're going to compute what this is. You're going to compute what this is and then plug it into the formula. So let's find it. So let's find f of 2 plus h. So I'm going to plug in 2 plus h in place of x for the function I'm given. So f of x is 3 minus x squared. So we're going to do 3 minus x squared. Well, x is 2 plus h. And then you just simplify that. So, well, this is a square. So we're going to have to expand this. So we have 3 minus. So if I do 2 plus h squared, that's 4 plus 4h plus h squared. So remember, you're expanding it. 2 plus h squared means 2 plus h times 2 plus h. And then we distribute the negative. So that's 3 minus 4 minus 4h plus h. No, hold on. Minus. I'm distributing the negative. So distribute, distribute, and distribute. Minus h squared. And then I can just combine 3 and 4. That's negative 1 minus 4h minus h squared. So that's the expression I'm going to plug in place of that piece right there. And then for f of 2 minus h, I'm going to again find what that value is. F of 2 minus h, and do the same thing. So we're doing 3 minus 2 minus h squared. And then again, you expand the term in the parentheses. So we have 3 minus 4 minus 4h plus h squared. And then distribute the negative. So that gives us 3 minus 4. Yeah, just double checking my work. Plus 4h and then minus h squared. And then again, I can combine the 3 and the 4. So that's a negative 1 plus 4h minus h squared. So that's going to be replaced in the place of f of 2 minus h. So this is going to be replaced right there. And then we divide everything by h. So we have f of 2 plus h minus f of 2 minus h all over h, and we found those components. F of 2 plus h is the first box we found. That's negative 1 minus 4h minus h squared. And then we're taking away f of 2 minus h, which is the last box we found, and you need parentheses because it involves more than one term. So that's minus 1. Oh, okay, don't know what happened here. Minus 1 plus 4h minus h squared all over h. That's the setup. And then here we're going to distribute the negative out to simplify this completely. So that gives us, let's see. So I still have negative 1 minus 4h minus h squared plus 1 minus 4h plus h squared all over h. And this is the cool part where you start canceling like terms. So negative 1 and 1 cancels out. And then, h squared and negative h squared, they also cancel out. So we're left with negative 4h minus 4h, that's negative 8h over h, and then the h's can cancel out as well, so it's just 8 negative. That will be the simplified answer for this difference quotient. Any questions?